Hello, everyone, and welcome to another episode of the Compelling Conversations podcast. Today, I'm very honored to be joined by Professor Miljanic. Professor Miljanic, thanks so much for being here.
Pleasure to be with you.
Yeah, I wanted to begin by saying that reflecting on my college experience so far, honestly, you've been my favorite professor. And that's because when I come to your class, it just felt elevated. It was always professional, it was always on time. You taught very clearly and you were very open to questions. You'd even repeat questions when they were asked, and people could hear and understand. So yeah, I wanna say thank you. I mean, it was my favorite class. A lot of people don't say that about organic chemistry, but it was my favorite class, and I think you played a huge role in that.
Well, thank you for saying that. I mean, as you might imagine, organic chemistry is not the most popular of classes, so I don't I don't hear it very often, but it's very very gratifying when I do.
Yeah,
Um, yeah, I mean, one of these things, the repeating a question after it's being asked. This is something that I've learned slash stole from one of my professors when I was a graduate student at Berkeley. So this is Caroline Bertozzi. She got the Nobel Prize recently. And she would always do that in these lectures that were even bigger than ours. That she would make a point of repeating a question and then answering it. And then everybody loved it because the way lecture halls are constructed is that the teacher can hear everything, but the students can only hear the teacher, not so much one another. And by repeating this, you kind of just make sure that you're answering a question for everybody rather than just the person who asked. So
yeah,
yeah, you'll learn.
yeah. It's cool that you got that from her. That was a very helpful technique. Because sometimes you can't hear what somebody else is asking. Professor just answers the question, but you made sure everyone heard, and it was a great part. And also, you gave breaks. There's like a 1 hour into the class or whatever it was, you gave a break, and then everybody came back. That was very refreshing as well.
Like breaks.
Yeah. A lot of people, before I took organic chemistry, they made it seem like it was a boogeyman, something to be afraid of. And it is certainly a difficult class, but it's not as scary as people put it out there to be. Do you also believe that?
Well, I'm of course biased because I am an organic chemist, so to me this thing was never really very scary. But I think that the class, there's a very predictable way to master this and a very predictable way to fail in mastering it. I think, in these large classes, a lot of people fall into one or the other of the categories. And so it, sort of to not master the class, I think what most commonly happens, and I've seen this on thousands of students by now, is that people fall behind, that they kind of start, start with material, they keep up with it, everything goes fine. And then for reasons that vary, I mean, sometimes, they have to take an out of town trip, or they get sick, or they just, feel overly confident, stop coming to class for a while, or just don't study for a little bit. They fall behind, and then they don't catch up again. And because the course is structured sort of in a way that whatever I teach you today, I will ask you to know it, or be able to apply it in a week. And whatever I teach you in a week, I'll ask you to know it in 2 weeks. Then if you kind of lose connection at some point, then it becomes pretty difficult to regain it, because it's not like we're starting, a new story every couple of weeks, and you can just ignore one story and then do fine, more or less. Here's just one whole story that lasts the whole semester. And so at any point that you miss a connection, that becomes a problem.
Yeah.
But I don't think that the material is very sort of intellectually challenging. I don't think this really strains, our brains very much. There's just a lot of it, but it's not.
Well,
Go ahead.
yeah, sorry, I didn't mean to cut you off, but I was going to say, I love how you said that because I remember that specifically, you saying that. And it's just the power of the things you say to people. If a professor were to tell me, hey guys, this is actually a very difficult class, that could sit in my mind. and that could change the experience for like a totally different way. But when you said, "Hey, it's actually not that challenging on your mind," like you can get a grasp of this. That's more hopeful. That's more optimistic. And it opened me up as a learner to be like, I think I can handle this.
Yeah, I mean that's true. Well, I think as a professor, kind of like a figure of authority, and so then whatever you say, people tend to kind of internalize it. But then I think things that you say to yourself are also very important. And there's this saying like, whether you think you can do something or you can't do it, you're right. So it's just like the perception that a lot of people come into the class with this perception that is coached by their friends or previous experiences, and they're like, oh, this is just going to be very difficult, and I set up to fail, and then they don't really. It takes a lot of time to change the perception, and especially if you sort of encounter some challenges in a class, which most people do. Then if you already came in sort of kind of thinking that this is not going to end well, then this just kind of validates that negative thinking. So it's I think people that never heard anything about organic chemistry from their friends and peers probably stand a better chance of doing well in it than people are burdened with all sort of stuff that share about this class.
Yeah.
But I mean, this the whole the sort of the responsibility for this class being quite difficult is not entirely based on just students' perceptions. It's there's a lot of universities, including ours, teach this class to these huge sections of 300 people, and then it's just not enough. The teacher-student ratio or one-on-one hours are just not enough. Right? So I think if we taught this chemistry in smaller classes, maybe 20, 30 people, which of course would require a lot more teachers because everybody wants to take this class to get into med school or some similar profession. But if we taught it to like 20, 30 people, I think people would have a lot more time to interact individually with the teacher, and I think the success rates would be significantly higher. Unfortunately, the person power to do that is lacking at most
Yeah.
places that I've been to. If you think about your friends that took organic chemistry at UH or anywhere else, they always tell you about this huge class, and the teacher comes in and can't even see him, and so they just don't get enough attention to sort of help you when you need it.
Yeah. Very good point. I wanted to go back to something you mentioned a little earlier about the internalizing something. I've met so many cool people in my organic chemistry classes, and some of the smartest people I met, I found something very interesting about them where they would internalize like, oh, I'm gonna do terrible. I'm gonna suck at this. But they ended up being the people with the highest grades. And I always thought that to be a very interesting paradox. Because to me, in my mind, it was like it's a self-fulfilling prophecy. If you tell yourself that you're gonna suck, that you're gonna suck. But these people, they were always worried about doing bad, but then they ended up being the best. It's strange to me. I don't know if you've ever run into anyone like that before.
Well, I don't know. I think it's. I mean, I have certainly, but I think everybody works in a different way, and some people that and I'm a little bit like that. They're just kind of like a warrior, like whatever happens is a cause for concern, and then that kind of a lot of people, when they worry about something, they tend to do something about it and not just worry and don't do anything. And so that's so some people, it sort of springs them into action. I don't know if this is sort of a conscious, or do people just do that because they know it will make them feel do better, or it's just kind of sort of the psychological makeup that there's some people that are that just tend to be more responsible. They kind of worry about meeting all these responsibilities, and then when they do meet them, then they do well. So I don't know. I think this is quite individual. But yes, I
Yeah.
have seen people exactly doing the things that you described. Not
Yeah.
not being terribly positive about it, but then doing quite well at the end.
Yeah, that's always fascinating. Um, there were so many interesting things in the class that I learned, but my most favorite one was maybe enantiomers because I remember reading Carl Jung and he talked about this concept called enantiodromia, which
All right.
means
Yeah.
yeah, we discussed it once
Yeah, we did
where
talk about this. Yes.
yeah, when a person has like a civil war inside of themselves, like two opposite factors, what ends up happening is enantiodromia. Neither of the two win, a third emerges. And I just thought it was interesting, like reflections and who we are and whatnot, and how that's exhibited even in organic chemistry to some extent.
Huh. That's yeah. I don't know very much about it. So in organic chemistry, when the two opposites enantiomers, the third one does not emerge. Although sometimes there's this thing called the conglomerate when you have these two mirror images of one another that have all of their properties be the same, including their solubility. But sometimes their mixture, their one-to-one mixture, has a different solubility properties from either one of them. And that sort of means that you can, if you have just a slightly enriched mixture in one of the mirror images, and then precipitation event starts, then that precipitate can become immensely enriched. So you can take a very small surplus of one enantiomer and amplify it to great numbers. And this is sort of kind of conglomerate pure enantiomer different solubility. But this thing has been kind of involved in in some theories about the origin of life and these chiral molecules on Earth that all come in one-handedness, but nobody knows from where, right? And so then there's some sort of amplification mechanism is sort of speculated, and might be something like that. So that's kind of the closest analogy I can think of. Enantiodromia, right?
Enantiodromia, yeah. He got the idea he got the influence from Heraclitus. But outside of enantiodromia or enantiomers, is there something about organic chemistry that's your favorite to explore?
Well, there's a lot of things. I mean, I think one thing about synthetic chemistry or organic chemistry in particular is that it's one of the rare sciences that makes its own object of study. Right? Because when you have astronomy, right, you study the stars that are out there. It's not that you can just let me make a star and see how it behaves. It's not possible, right? And something similar with the principles of with a physics. Even though with this physics of elementary particles, you can kind of make things that were either rare or do not exist in an easily observable form. But for synthetic organic chemistry, we routinely make new molecules, sometimes just to study them, sometimes to see how they behave, what the biological activities, how they look like, what kind of reactivity would they have. And so most of my PhD students will make, anywhere between 5 and 50 or more, completely new molecules unknown to mankind before they started. And that's pretty routine in this field. So that kind of means that the subject of its study is inexhaustible on one hand, and then also kind of there's kind of a critical mind that is necessary, because you can make all of these molecules, and people have made close to 100 million organic molecules. But why should you, or why would you? Right? Which ones should you make, and why? And so some sort of a molecular design, which is kind of related to design in general, is sort of necessary. Like what would this do better than the previous examples, if anything? So that's one thing that's kind of is sort of allows for a lot of creativity, and it's quite unique. The other thing that I share with a lot of my colleagues is that that chemistry has sort of an interesting combination, a kind of nice combination between being very practical, because chemical industry, and especially Houston areas, so much chemistry in real life that is being applied to problems in oil industry, petrochemicals, and whatever.
Bananas.
Bananas ripening, yes.
Remember,
And but at the same time, it's kind of very fundamental, and then you can like learn sort of very principles of nature without having to worry about any of these applications. I think very few sciences have that combination of just fundamental curiosity and practical applications.
yeah, it's so unique, so fascinating, and I'll admit there was a time where I hated it, a lot. But then I found like I could really love it, and that was such a fascinating transformation. You mentioned inexhaustible. That there's so much to study; it can be inexhaustible. Do you ever get exhausted of organic chemistry?
Yes. Well, this is sort of a definition of research. I mean, apart from teaching, I do a lot of research with my graduate students and postdocs. And then, we have all these great ideas and they all look fine on paper. But then when I don't do much experimental work anymore, but they do, and when my coworkers do these experiments and they much more often than not, they don't work. They don't give us the desirable result. Some they don't give us any result. And so that ends up being quite frustrating, first for them, but then also sort of for me. And this is the reason why you call research, that you search for something and you don't find it the first time, and then you have to research for it. But this is sort of a process that is pretty frustrating and sort of it's full of disappointments. And it's kind of not unique to chemistry. I think a lot of research in many disciplines has a lot of dead ends and failed starts. And that kind of requires a personality makeup that is, not easily discouraged, but still at some points realize that, nature is trying to send you a message that this is so it's kind of like, we sort of constantly revise these outlines of these projects, in that we start with one idea, then it doesn't work, but something else might work, but how related or important that is, we weigh those things constantly. With the idea that we both work on something that, we are actually revealing some new things about nature, that rather than, looking at a bunch of dead ends. And at the same time, we're working on something challenging and sort of competitive on the world stage.
Yeah.
So yes, I do get exhausted of it very often. This is also one reason why teaching and research are kind of a nice combination, because on many of my sort of research down days or weeks or months, when nothing seems to be working in the lab, then by going to teach my class two times a week or however many times, I was like, oh well, this teaching, most of the time, if you're well prepared, teaching works. You teach people something, and then it kind of like, oh well, my work does have a purpose, which is teaching, right? And that kind of serves to shave the rough edges of research, which goes in big ups and big downs.
Yeah, absolutely. And even the effects that you have on your students. Like I remember my circle of friends, we all shared the same opinion. You're an excellent professor. Like you had an impact on us. I remember you would ask the class, like, is anyone in here just for the sake of chemistry? Um, what drew you to this just for the sake of chemistry?
Well, it's at the time when I started studying chemistry, I studied in Europe, in Serbia, and there the educational system in college is quite different, in that you don't really choose your classes or your majors, or you choose them but only once. You commit to a major basically straight out of high school, and then you stick with it. Then to switch it would require basically starting over. And so then kind of forced to make this really life impacting decisions at a very young age of 18. And at the time, I wasn't really sure that I made the right decision. And I don't know. I'm still not sure. In that, I had a lot of other interests. I mean, I was very interested in, in computers and programming languages. I was interested in linguistics. I was interested in writing. But kind of, you have to choose one thing. And of course, I was interested in chemistry. But then you sort of, as you kind of choose that one thing and starts getting on a path, then you start getting more and more into it, or at least I started getting more and more into it. In that, that sort of opens up these opportunities to learn something, to attend a conference, to do cool experiments. That at some point, you really are so invested in this path that other paths that you might have taken at some point in your life don't have such a draw anymore. So yeah, basically, to answer your question, I was pretty clueless when I was making that decision at the age of 18, really. But since then I have grown very much into it and started, nowadays I explore some of these connections with interests that I used to have and that I have developed since, and chemistry, right? And so a lot of chemistry is connected to energy and sustainability, and so I set up a class that I was teaching that had chemistry but also other disciplines in it, and so you sort of don't have to dedicate yourself to a single field of study very early on. And many people would argue for not doing that, just staying generalist as long as you can.
Yeah, like a jack of all trades, eh?
Something like that. Yeah.
Something like that. Is there a concept like that in organic chemistry? Does something operate in that way? A jack of all trades can interact with almost everything.
Uh, to an extent, yes. In terms of, there are reagents, chemicals that will react with a great many other chemicals. But I think, much like jack of all trades is oftentimes, when you're talking about a person, followed by and master of none. Also, something similar, happens with chemicals that are reacting with great many other chemicals. They tend to be non-selective in their reactivity, which means that they're not terribly useful for producing pure chemicals with very desired targeted transformations. And so, now, of course, they have their own benefits, but I think in many reactions, we seek things that are very much specialized, that react with only one of the dozens of functional groups present in a molecule, very selectively, with high specificity for a specific product. So there's, sort of like for people, I think there's space for both highly selective and highly unselective reagents in chemistry.
Yeah, that's a very good point. That's cool. Do you with your class this semester? Or actually with every semester as the classes change, is there a common thread that you notice in all students, and is there like a common difference that you keep seeing?
Well, I think students sort of change and evolve a lot. The one thing that I've noticed this semester is that almost nobody has a physical textbook anymore, that everybody has switched to electronic things. And these electronic textbooks, they were out there for probably past 10 years. But I think this was the year when I really noticed that nobody has a book anymore, which, I think is, and some things change, some things evolve. After COVID, we saw sort of a big drop in student performance, which was caused by COVID fatigue and sort of the fact that these classes were switched to a very crude remote version initially. Now we kind of recovered back to what used to be pre-COVID. And one thing that I've seen sort of over and over in students in these large classes is that the challenge is not so much delivering knowledge, because I have classes and I have recordings of my classes and I hold review sessions, and and all that. And so, and then of course there's textbooks and all these online resources. So students that are looking for information, they can very easily find it. And if they're looking for an answer, they can also very, very easily find it. I think the bigger problem in the class performance overall is that some students are not looking for this. And the reason for that is that we are not, as teachers, not able to engage the entire class. And so that some students very early on disengage, and it's quite difficult then to connect with them. And so what ends up, what I used to think will kind of help there is, oh, well, if I just hold one extra review session or, extra set of office hours, that's going to help elevate the class's performance as a whole. What I've realized since is that this doesn't really work, that these sort of extra resources that I put in oftentimes benefit the students that don't really need them. Students that would have gotten an AX anyway, they're the ones that show up to this extra office hours. And the ones that really do need them, because we have lost them on the engagement front, they don't benefit from this. And so I think what one of my focal points being going forward in these large classes will be to seek a way from very early on in the class to engage students that are at the risk or that I notice disengaging. And that, of course, becomes a lot more personal and a more difficult question to answer.
Yeah. When you were teaching in COVID, what was that experience like? What did you notice?
Well, I think I don't know. I think small classes could work pretty well because it was difficult for somebody to just log in and then go have lunch if it's a class of 9 people, right? Because I would call on people, I would ask them, and so it's pretty obvious if somebody's just there on somebody's name is just there on a screen without the actual person being there. Now in large classes, this was literally my biggest challenge, that would be maybe 2 or 3 people would have their cameras on, and maybe 5 or 6 more would talk. Everybody else, the computer told me that they were there, but I didn't really notice them in any way. Maybe they noticed me, but what I think the problem there was that it's just very easy to lose focus in a class anyway, and it's so much easier to do it when it's on a little screen, oftentimes with glitchy connections. And so I think the class size is kind of a challenge without COVID or with COVID. But I think once you get to these online setups, then it becomes a challenge at much smaller sizes, because having, as you probably know even now, if you go to an online meeting with 50 participants, 30 of them might as well not be there, because it's not going to be an equitable conversation. One thing that I did notice, especially in early COVID, is that people that it was sort of the shyness pattern would switch a little bit. So people that would not speak during class in person in that first semester of COVID teaching, when the first half of the semester was in person and then we switched to online, they would become a lot more vocal online, and especially if their cameras were off, because I think this sort of awkwardness or whatever you want to call it kind of played differently in the online world. And another positive thing that I noticed was that in many large classes, you sometimes have 1 or 2 people that tend to monopolize the conversation, and they're the ones asking all the questions. And that's not all that great for the whole class, even though I think those people learn quite well. It's much more difficult to do that in an online world. So I think the conversation kind of ends up being more evenly spread.
Yeah.
Now, one thing that we really liked from COVID is the office hours, because office hours, we call them office hours because they're happening in my office between the hours of 9 to 5. And turns out that for students, this 9 to 5 doesn't really work because that's not when they study, that's when they have work or that's when they class. But the time when students ask questions is when they start studying and like, oh, I don't get this. Wish I could ask somebody. And that doesn't happen between 9 to 5. It happens in the evening or the weekends or sometimes. And so during COVID, I sort of set up office hours online because everything was online. And now I still do them online because that allows me to talk to students in the evening, 7 or 8 p.m. or over weekends. Oftentimes these are very quick calls, so it doesn't really take much of my time, and they really appreciate it. And it works much better with their schedules. And that was kind of an unexpected discovery, but it's a good one.
Yeah. For myself, I'm very grateful that I got to take it in person with you because, as I mentioned, I think you facilitated an environment where I could thrive, where I could flourish. I felt like I could flourish. It felt like a place to be where I was really learning something. I was really being productive. It was, pen on paper. I had to learn it myself. I had to do it myself under your instruction. So I'm grateful for that experience. But yeah, I was just curious, what was it like online? It must have been a different world, you know. But we're coming closer to an end. I'm curious, do you have any closing thoughts? Anything you felt like you wanted to say but you didn't get a chance to, or something on your mind that you wanted to express?
Well, maybe I could do a plug for my study abroad trip, if you don't mind.
Absolutely. Go ahead.
Right. So I like chemistry and I like to travel and I like energy. I'm interested in sustainability technologies, and so this next spring, so in late May, a colleague of mine and I are organizing a study abroad trip to Chile and Argentina. So my colleague is Professor Eduardo Aleman, who is a professor of political science, so very different from my experiences. But he's Argentine, and our trip would take students to Chile in Argentina to look at the lithium production. And so lithium is sort of a mineral, so that's why the chemistry interest comes in. But that mineral is sort of critical for new battery technologies, for the development of electric cars. And Chile and Argentina are playing a crucial role in it because they have about 50% of world's reserves of lithium together. And so what we would like to see is how are they exploiting this, how they plan to regulate that, and at the same time sort of look at these two countries, which are sort of very easy to travel to, very cool places, great food, interesting culture. Also, for a lot of our students, this would be countries that speak Spanish. We have a lot of bilingual students that I think would benefit from that as well. And so basically, we're planning to do this thing about mid to late May, 10-day trip, half of it in Chile, half in Argentina, with a great combination of culture, sort of just kind of exploration of cool stuff to do in these two places, but also we're going to go to a Ford plant, to a lithium mining company, talk to professors and politicians who are interested in this topic, and just have a great and educational time. And so if any of your listeners are interested in this, they should look either me up or Professor Eduardo Aleman. Send us an email and we can start talking about this.
Yeah, I'll definitely include your email in here. Thank you for sharing that. It does sound like an exciting trip. Yeah.
It should be a lot of fun. I've done one of those to Iceland in 2017, and it was so successful that 3 of my students didn't want to come back. They wanted to spend a couple of extra days there, which they did. And one of them actually ended up attending graduate school in Iceland. So,
wow.
So it was really, and at some point in your academic career, these trips can really be quite life-changing. And so hopefully this one will be as well.
Yeah, hopefully. Speaking of Iceland, how often do you get mistaken for being Scandinavian? Because when I first met you, I thought you were Norwegian or Swedish.
Quite often, actually, and for some strange reason, when I get mistaken for some other culture, it's always Scandinavian, and when it's Scandinavian, it's almost always Norwegian, never Danish, never Swedish. I don't know why. I've never actually been to Norway, but yes, that's a common one. I take it as a compliment. I think these are great countries.
Do you know what? Do you mind sharing what your name means, Ognjen Miljanic?
Right. Yes. So I'm originally from Serbia and so former Yugoslavia, and my name, both my first and my last name, have sort of Slavic origins. My first name, Ognjen, is related to the archaic word for fire, and the last name Miljanic or Miljanic in an Americanized version as sort of means kind of deer or something along those lines. Not deer the animal, deer the adjective. So yeah,
Cool. Thanks for sharing that.
that's me.
And thanks so much for being here. It was truly an honor. I really appreciate this. And yeah, it's been a great time talking to you.
That's a great chance. Thank you very much. This was exciting and fun. So,
Absolutely. Yeah,
good
well, I
luck with
suppose
it.
until next time, eh?
Bye.
Yeah.
Thank you.